Honourable Chairman, Honourable Ministers, Excellencies, ladies and gentlemen, it gives me great pleasure to represent the Group on Earth Observations at this inaugural ceremony of this ECMOT organized conference on climate change and adaptation in the Himalayas Hindu Kush region. Actually, if we really want to understand and improve our ability to adapt to climate change in mountain areas, we have to realize that this has to be brought into a broader perspective, because climate change is an issue and that we are facing in the future, but it is clearly not the only one, and we must recognize that it is connected to other challenges that we are facing. The population on this planet will be increasing, presumably up to 9 billion. The GDP in developing countries will be increasing to a level that of more developed countries. Climate, indeed, is warming, but we also see a decrease in biodiversity and a gradual destruction of important ecosystems. And this will create a lot of demand. The demand for more energy, more food, more fresh water, more housing space. We'll also want to preserve and improve living conditions and health. And all these challenges will have to be addressed in the context of the end or the recovery from a fairly severe financial crisis, which doesn't make governance more efficient and in an easy condition to respond to all these needs. So there will be two ways to address these questions. One will be a series of technical solutions. We'll find new energy sources, renewable energy, solar, wind, nuclear energy, hydropower. We will probably be able to develop new crops which will be resistant to droughts, to pests. We'll develop more efficient buildings and new way to build cities, more likely like Shanghai and Hong Kong than Los Angeles, meaning reducing the footprint, and develop new vaccines, new treatments. And there's another route to solve this problem, which is environmental management solutions, those based on understanding the Earth and based on Earth observation. It's interesting to result. We'll actually use the two threads, the two series of solutions, but it's interesting that even for implementing the first ones, we will need Earth observation. To locate, to site solar plants, we will have to understand the distribution of high solar radiations. Even for nuclear plants, we'll be able to ensure that water will be there for cooling. And of course, hydro water will require an understanding of the environment. So it goes for all the other solutions. So it is clear that in the future, Earth observation will be needed. This is a good example, an illustration of these two alternative threads. It's a well-known example of New York City. It turns out that New York City is getting 90% of its excellent tap water from a watershed called the Catskills. And over the last 10 years, because of the increased population, the quality of this water has been degrading, so that they had to find a solution to restore the quality of water. And there were two solutions. One was to create a filtration plant, which cost was estimated to be between 6 and 10 billions, with an operating cost of 100 millions. And it turned out that a good analysis of the Catskills showed that restoring the quality of the watershed and its natural efficiency would only cost a few $100 million. And the consequences for health and safety are enormous, because by turning to natural ecosystem services rather than a plant and chemicals, we will obviously improve the quality of life in this area. So this is the kind of choice that governments will have to be making in the future. So, recognizing the need for using Earth observation to inform decision-making, governments from 82 countries with the European Commission and 58 participating organizations, including ECMOG, got together to establish an intergovernmental group on Earth observation. And the purpose of this group on Earth observation is actually not to do science, Andreas. It's to create an operational information system. We refer to it as the Global Earth Observation System of Systems, which is actually the coordination and the interoperability of all the resources that members and participating organizations operate. Satellites, in situ observing systems, modeling capabilities, forecasting capabilities, scientific knowledge. But all of this in order to provide information to support decision-making by governments for the benefit of society. And to do that in 9 societal benefit areas, not just one, but 9, not just climate, but disaster, health, energy, climate, agriculture, ecosystems, biodiversity, weather, and water. So the vision for GEOS is to create a world where decisions and actions will be informed by coordinated, comprehensive, and sustained Earth observations. And the other thing that GEOS recognized is that we live in a complex world, a complex system of systems, and that's why we wanted GEOS to be addressing 9 societal benefit areas at the same time, not just one. It's because all the issues that governments have to deal with, on which they have to make decisions, are interconnected issues. Let me give you another example, which is a very important decision that governments have to make, which is the attribution of land or land use. For many thousands of years, we had a picture of the world which was pretty simple. We had urban land, urban area to live in, and agricultural land to produce the food for us. Then, lately we realized that forests are also important. Forests are important for many reasons. They're important because there are communities living in forests that need to be supported. It's also important because we realize that forest can be a major driver in reducing carbon emissions, and also forest is producing a wealth of ecosystem services. We've seen how it filters the water in the Catskills, but it also can protect coastal areas from tsunamis and hazards. So it has a lot of potential, it produces a lot of potential services. But actually the picture is even more complicated because there are other ecosystems like forest, which are important for maintaining a sustainable living conditions on the planet. There are wetlands and of course mountains. And the subject of this conference is to address in particular the mountain ecosystems and how it should be preserved and managed. And actually the whole story is even more complicated because now this is interacting with energy policies because we need biofuels and biofuels will interfere with agricultural land. So you see, anytime, and that's why our governments are in a difficult position to make decisions, and that's why the technical community that is assembled here should actually put together all the resources to address these questions. And this is really the purpose of this seminar. So I will, I guess very quickly, this seminar is about bridging the data gap. Actually, as Andreas Schild properly put it this morning, it's bridging the knowledge gap. Data is one thing, but in the end, what governments need is information. So we need to bridge the knowledge gap so that we can bring the information to the people to make decisions. The way GEO is contributing to doing this is by supporting data sharing principles. In other words, making sure that data, when they exist, in particular space data, can be shared with all potential users as fully as openly as possible. And we've been quite successful, and China and Brazil 5 years ago, decided to distribute the data from seabirds freely. And this was followed quickly by the US, which decided to release the Landsat image. So there have been a lot of progress in making sure that data can be accessed and there is no restriction on sharing this data and bridging this data gap. And then, of course, we have to ensure that we can, technically speaking, have access to information and all users, potential users, can access the information. So that can be done through the internet. That can be done by broadcasting information from satellites. And yesterday, we had the inauguration at ECMOD of the wind receiving station, which will allow ECMOD to receive through a broadcast the data from Japanese satellites for managing disasters. Tomorrow, we'll see the inauguration of Servier, produced by USAID and NASA, which was initially developed for Central America and later was actually implemented in East Africa and now will be implemented in the Himalayas. So these are examples of how the data gap can be bridged by bringing the information to people. But again, what is important is to bridge the knowledge gap, to build the knowledge so that the information can be used and transformed and to produce the right information that governments will be needed to make the right decisions to improve the quality of life of all citizens.